Hello, differential equation students. Here we have an initial value problem, and it's an initial value problem because we have a y of 0 equals y naught. Y naught is called the initial value. The independent variable is t. T is set to 0, and when t is set to 0, we get this value. We're going to determine what that y naught is in a moment. Here is the ODE, and you'll see by the end of the problem, by the end of the solution, we're going to know what the k and the y naught are, and normally that will be how the problem stated, and we want to go about finding this y of t here. But for now, we're going to work backwards, and we're going to determine what the k and the y naught are. All right, and hopefully in the process we'll learn a little something about this problem, about solving initial value problems. Okay, first thing, I'll just rewrite the ODE. Then I'll take this solution, this y of t, and I'll substitute it into the ODE. So now you can see here we put in the 2e to the minus 5t for y. Then we're going to prime that. So that means we're going to take the derivative, and the derivative is with respect to t. So let's go ahead and do that. And when we take the derivative, we use the chain rule, so the minus 5 drops down, and we're just going to multiply that out, and we're going to actually factor out the e to the minus 5t. And when we do, we have the factor theorem. We have e to the minus 5t times this quantity, so one or the other must be 0, but because the exponential is not 0, it must mean that minus 10 plus 2k is 0. So that implies that k is equal to 5. So we'll put that in there, and now we solve for k, and now we're going to find out what this initial value is. Okay, so keep that in mind. We'll store that information. And now we're going to use the initial value. So we're going to plug in t equals 0. And when we plug in t equals 0 on the one hand, we were given y naught. On the other hand, we plug it into the solution, the 2e to the minus 5t. And remember that e to the 0 is 1. So that implies that y naught is equal to 2. So let's put that in. And notice that the IVP, the initial value problem, then is given by y prime plus 5y equals 0. And the initial value, y0, is equal to 2. Okay, and this has the solution, y of t equals 2e to the minus 5t. This 5 here is called the constant of proportionality, and if we move the 5y over, you can see that the derivative is equal to is proportional to y, and that proportionality constant is minus 5. The 2, that is the coefficient of the exponential term, comes from the initial value when t is 0. You're going to see this over and over again as we solve problems, initial value problems like this. This is a very important type of initial value problem, and it'll come up quite a bit when we're studying population models or growth and decay models. All right, good luck.